Hello everybody, my name is Michael Merrington. I'm the General Manager of Index. We are sharing our knowledge, experience, competency amongst others to hopefully give a viewpoint outside of your activities. Perhaps some engineers do not have field experience, or installers do not have maintenance and operations experience, or manufacturers don't know the requirements of end users, and end users don't understand how what they receive is how it became the way that it is in the condition that it is. So I'm going to turn off my webcam now so that we can start the presentation. Once again, thank you everybody for coming. So, equipment ingress protection, what's involved? The equipment, the glands, IP washers, the cable. So, first question. Is IP68 device rated for IP66? %48 have voted. Hopefully we can get 100% this time, but 70%. 75. Let's hit that 90% mark. That would be great to get everybody's feedback. This is a very contentious issue. Those who watched the last presentation should know the answer. 85% voted. 3, 2, 1, close. Okay, so 29%, remember this is anonymous, 29% of you, that is incorrect. IP68 is not rated for 66. Please watch Index webinar number 4, the last one on YouTube. We will share the link in the email to you. IP68 is not rated for 66. So, why? Well, IEC 60529. There's different test parameters, test lengths. During new conditions, but what about ambient conditions? This is a question for later in the presentation. But basically, on the right here, this tank is an IP67 or 68 test tank. On the left is for IP53 or 54. On the bottom here is an IP66 test with direct jets of water. Why is 68 not rated for 66? Because it is clearly identified in the standard IEC 60529. When you look at IP68, it says it is restricted. If you go across, it's good for temporary immersion, submersion. For water jets, it is not rated. Okay? Full stop. IP68 is not rated for 66. 67 is not rated for 66. 69 is not rated for either. 66 is rated for all the numbers below it. 68 is good for 67 as well. 69 is only for 69. So, ingress protection in hazardous areas. We get told quite a bit that ingress protection has nothing to do with hazardous areas. Well, that's interesting. Ingress protection, the word ingress is mentioned 74 times in the repair standard 60079-19. It's also mentioned 24 times, the 60529 standard, within the general requirements of 60079-0. So -0 is for manufacturers, -19 is for for repairers, repair facilities. The manufacturer perhaps does the repair. But why is it that the standard, by searching by the standard, under installation, selection, and erection, it's only mentioned 1 time, but the word ingress also only 11 times. But under the maintenance and inspection standard, ingress protection is only mentioned 0. The word ingress is only mentioned 4 times, while 60529 is only mentioned 0 times. So why is it that ingress protection is very important for the manufacturers during building of their product and design and testing, and also during repair? But why is ingress protection not talked about during installation, initial detail inspections, operations and maintenance? Is an electrical equipment with water inside extremely dangerous? Yes. Yes, it is. Now, video. See if it'll play for you guys. Now, I'm gonna raise a poll here. What are the potential paths of water into this device? Not this specific one, but what are potential paths? This is multiple choice. What are potential paths for water to enter a device? %30 voted. I'm gonna wait till this one gets about an 80%. Once again, if you can't see the videos when they're playing, they will be on the YouTube channel and you will get the link. 76% voted. That's multiple choice, guys. Okay. Now, what are the paths for potential water ingress? Guys, every single way. Through the cover or the lid, a broken seal, a loose lid. Through the threads of the gland threading into the device. Through water vapor, humidity. IP ratings do not matter when it comes to vapor or gaseous form of water. When humidity gets into a device, when it condenses into water, the water's now inside. IP ratings only stop solids and liquids. Yeah. Through the threads of the gland body. So through the other threads of the gland. So not just the entry thread, but the actual other threads, the main body and the back nut. Also, in this video, where the water came from was up the cable. Okay. Other people have found this out. At the bottom here, a gentleman made even IP66, if it is not followed proper, the IP means nothing. But also he had said, from my own experience, I've seen water enter the JB through tiny cuts in the outer sheath of the cable. Piping of water up a cable. Different temperature, height, and pressure will make things flow up a cable. Next. Now, let's see if these will play. Water, hydraulic fluid, gas, and vapor readily come up cables into extra low voltage, medium voltage, high voltage, safety instrument systems, and fire and gas devices. Subsea cables can have hydrogen, condensates, and hydraulic fluid come up them. I, for one, have personally experienced this. Is this not a major safety issue? See the bubbles? See the gas, maybe air coming up the cable? We don't know. Now this bottom video is a flame propagation test. An EXD explosion, where does the flame from inside the box go? The flame is going up the cable and even the individual cores. So, what does that mean? What cables make for great pipes? They'll freely allow for the flow of water, gas, any liquid, vapor, gas to go up. Okay. Now, what about the individual cores? Will they allow water or gas to go up it? Well, here's a little gas test. Very little pressure on the cores. Gas going up the cores. So are any cables perfectly circular and compact to stop gas from going up it? No. Now, water ingress to devices. We're told in the hazardous area industry that ingress protection does not matter when it comes to the EX protection technique. This is a high voltage motor, 6,600 volts. Now, if you take a look in the bottom right, you can see all the condensation in there, but also in there, there's puddles of water within a high voltage terminal box. Now, the bolts inside don't have IP washers, so water is now going down into the motor. How did the water get in there? Well, they have a little anti-condensation pack, which is not enough for certain locations in the world where there's 100% humidity. Also, there's clear indication on the bolt holes that water was getting in through the bolts. So perhaps the manufacturer, the testing laboratory, perhaps they both made multiple errors on this. So would we say that the water ingress affects the EX protection technique? Well, this terminal box is EXE. Water causes problems with creepage and clearance distances, arcing, sparking. Certainly IP ratings have a very important effect on EX protection techniques. Once again, I would like also to say that CCG Cable Glands are our sponsor for this presentation. Okay, so who accepts all responsibility if something goes wrong? Well, it's the end user, the owners of the facility. They accept all financial risk, reputational risk. If the contractors or subcontractors hurt themselves, kill themselves, they are at fault. The end user. Somebody asked about solid or stranded cable. Within the international industry, we primarily use stranded. We do not use solid cores in oil and gas very often. The end user also accepts complete occupational health and safety requirements, environmental requirements, and they have to consider all other stakeholders, such as shareholders of the company. Now, why is this important? Well, in Philadelphia last July, sorry, that would have been May, there was a giant explosion. 1,300 people lost their jobs. So who's responsible? The end user. If there's water in things and something blows up, was it the manufacturer's fault? Possibly. Was it the maintenance worker's fault? Possibly, but who accepts all the risk? The end user. And then who has to pay for that? The workers. They no longer have work. Oh. What considerations are called for when it comes to ingress protection and other environmental conditions? Well, according to 60079-17, inspection and maintenance, which is used by operator maintainers, environmental conditions such as high temperature, low temperature, pressure conditions, corrosive environments, vibrations, wind, solar radiation, chemicals, water, moisture, dust, and dirt. Okay. That's for the owners and operators, which ingress protection is barely even mentioned in their standards. Well, what about for the requirements for manufacturers? -0. What's their responsibility? What's their risk? Well, when we compare the two different standards, the owner-operators on the right have a lot of risk and a lot of considerations they must consider. Now, does an end user know about all these or have experience with all these? Certainly not. Owners sometimes have different companies operate and maintain their facility, or they trust the EPC, the engineering, procurement, construction, and management company during the construction phase. So are the end users, the owners, considerations, responsibilities considered by these other companies, such as the manufacturers and the EPCs? Perhaps not. Now, why is it that when we look under the 0 standard for environmental conditions, it only talks about ambient temperatures and electrostatic considerations? Why are the environmental conditions not clearly defined and highlighted at the manufacturer level? They talk about ingress protection, 74 times in one document, but never in the in the maintenance and inspection. But then the environmental conditions are, but then why aren't the environmental conditions mentioned to the manufacturers? There seems to be a gap here between manufacturers and end users, between EPCs and end users. I'm calling to question this. What's happened in the industry? Well, a manufacturer was found that their lights did not meet IP66. So what happened? The end user, they lost tens of millions of dollars. They had a damaged reputation. The manufacturer, well, they were just sold off to another manufacturer. A couple job losses. Now, water getting into it, it's unsafe. Now, what happened to the testing laboratory and the certification body of those lights? Did they test them right? Did the manufacturer do something incorrect after the fact? The point is Hadar lights went under and was sold off, and people lost their jobs. And this affected many projects for tens of millions of dollars because the IP rating was not as it was said to be. Now, testing of equipment and glands. We call it the entry interface. Before the 7th edition of this standard, IP testing was carried out after thermal conditioning of the gland and after impact testing, but excluding the entry interface. So this picture shows you a test that would not meet the current requirements, the current standards, edition 7. There's no cable and no entry device entering that device during this IP66 testing. This test means nothing. It is not sufficient. It would not meet requirements. Now, edition 7 called for IP testing the interface, so the cable gland threading into the equipment, it had to be installed. So if they said it's IP66, it would call for the use of an IP washer at all times. You always require an IP washer to get IP66. Now, the use of a sealing method shall be specified by the gland manufacturer, but it's the equipment manufacturer having their equipment tested. Do they care about which gland is used? No, they don't consider that. If the gland manufacturer is having their gland tested, what device is it being tested on? There's hundreds of thousands of combinations. So are those tests all possibly done? Of course not. So after also thermal conditioning of the seal. So what that means is that they're heating up the IP washer. So if it's nylon, plastic, can probably handle that heat. Can a fiber IP washer perhaps handle the heating and the water on it? I'm going to call question to that, which we'll see in later slides. So, under the old edition, thermal conditioning of the sealing method, so the IP washer requirement, was not understood by some EXTLs, test laboratories. So some glands in the industry have been incorrectly certified. So we have evidence of this. So not all glands are equal. Now, there was a decision sheet, engineering assessment done by the IECEx. Basically, it does require that the washer or sealing method be subjected to thermal endurance test prior to the IP test. You have to stress it. But I still call into question, when you're doing IP testing, you're doing it on a new device. What about that device in 5 years, 10 years, 20 years? When Samsung tests their phones, let's say the Galaxy Fold, they do testing to see how many years it will last. You don't seem to do that for IP testing. What about the device in so many odd years? Now, insufficient testing can lead to product failure. This was 6 months after installation. The IP washer failed. Water got in and caused corrosion. So who is responsible for the financial, the time, and the reputational issues of this happening? The end user. So if the manufacturer sold them a cheap gland, or the EPC purchased a cheap gland without considering the environmental conditions, well, the end user, the likes of major oil and gas companies, yeah, Chevron, somebody like that, now it's their responsibility. It's not good. So you see the issues, yes? Everything goes to the end user. The cost of being cheap. Fiber washers. By the way, fiber washers are an accessory that plumbers use. They absorb water to form a seal to ensure water tightness on a water line. They're not for rain tightness. Fiber washers are no good for wet environments, petrochemical environments, cold environments, where there's big temperature swing. See here, it's breaking apart. Also, it's not UV rated. So it's not for use outdoors. Yeah. If it's not used for outdoors, why is it still used? Misconceptions within the industry. Even the manufacturers on their website say that careful consideration should be given to use of their fiber washers. Why do the manufacturers still sell fiber washers? Because some end users still unfortunately ask for it. If the manufacturer didn't provide the fiber washer, they then perhaps wouldn't get the job of selling their glands to that end user. Chicken and the egg. Does an IP66 device with an IP66 gland require an IP washer? Well, if you want anything greater than IP54, install the IP washer. If you don't have an IP washer, what is the point of buying a device that is IP66 and a gland that is IP66 if you're not going to maintain IP66? Water is a serious issue for everybody's safety and for the longevity, the life, the maintenance of the facility. 6 threads of engagement only give you IP54. But there's other considerations. The surface roughness of the device. If it's a GRP, a plastic box, does the wall flex? Yes. Is it still IP54? No, not at all. So according to edition 7, you always have to have the sealing method to test for IP66. So the only way to get IP60, the only way to have a safe quality installation, install the nylon, plastic, or rubber IP washer. Fiber washers, only indoors. No chemical processes, no petrochemical environments, no big temperature swings. They only absorb water and cause failure. Advantage of not being cheap. Maybe it costs you an extra 1 cent per nylon or specific IP washer. Well, it has a higher temperature range, -60 to 150. It's UV rated. It's good for IP66, 67, 68, 69. If you read the manufacturer's requirements, the only way you're going to get IP67, 68, or 69 is 100% use of a washer, IP washer. Also, they have long life. Look at this example. Those black IP washers here, those have lasted 16 years. Now, cost of being cheap. Brass glands. Why are brass glands used? The only reason is because it's cheap. Or misunderstanding within the industry. So what are the problems with brass? Well, you can't do an inspection on this now. You can't read the EX information. It's going to break off like in the other picture you saw. Dissimilar metals causes corrosion and then it welds to the device, so you can't get it off. So why do we use brass glands? Because the end user perhaps doesn't know the difference of why it's bad, or everybody just looks at, oh, we saved $5. But in the long run, it probably costs them thousands of dollars or hundreds of dollars per gland, let's say, because not only do you change the gland, you also have the man hours to do it. And to install something after it's already been installed, you better times that time by about 300%. Now, why are brass glands used? I would say there's multiple answers to this one. So 2 answers are the exact same, by the way. So I would answer to yes to both of them. 80% voted. Okay. So why are brass glands used? Because they're cheap. It's a cost-cutting method and lack of awareness within the industry. Now, for those who said that it's fit for purpose outside, how much more evidence do you need? If it costs you an extra $1 per gland, why are you going to put your personnel and your facility at risk? A corroded device that disconnects, now the cable is no longer earthed. You are putting equipment and personnel at risk of electrocution. You've lost your earthing. Please be aware of all considerations of cables, glands, and equipment. To make assumptions is to put people's lives at risk. And the end user now have an expensive maintenance activity that they shall have to do. Now, what are the advantages of not being cheap? Well, you can use nickel-plated brass for the following reasons. It doesn't react with dissimilar metals. It can be used in nearly all conditions. It can be used in all environmental conditions. Doesn't matter the temperature, the IP requirement, dissimilar metals, or corrosive environments. Now, the importance is how many microns, how many atoms of thickness of the nickel-plated brass is. The standard has changed where they now have to be, I believe, 10 microns or more. Back in the old day, these manufacturers learned their lesson. Yeah. So brass glands, they are not needed. Now, the best solution is to use a nickel-plated brass because it doesn't react with any of the chemicals, the salt, the environment. It lasts a long time. Now, what's the cheap solution that everybody came up with? I think people are going to say shrouds. So why are shrouds still used? Multiple choice. Somebody said that shroud equals a water trap. That is correct. Once again, like brass glands, shrouds are a misunderstood item within the industry. %70 voted. Let's get up to 90%. I want everybody's. By the way, there's multiple answers. $83. Okay, good enough. Let's share. Why are shrouds still used? Yeah, the customers asked for them. They sell every single gland. They sell it with a shroud. Why? It's cheap for them to make, the manufacturers, and they make money on it. So the misunderstanding by the end user, they're costing themselves money. I'll explain why later. Manufacturers make money off them. Yep. It's an industry-wide false belief. That's the 100% answer, that they stop water and corrosion. They do not. They hide damages. Oh yeah, this is a perfect tool for EPCs, for installers, because it hides any quality and safety issues. If you can't see the problem, they just make their money and they walk away. Now, the 4% that said they are wonderful, I really hope you accidentally hit that option, let's just say. Now, nickel-plated brass, by the way, is non-sparking. It's correct. And every shroud, well, let's have a look at shrouds. What do shrouds do? Shrouds are used because it was a bright idea from some engineer. Did that engineer have field experience? Did that engineer know of all the other EX requirements? Did that engineer actually test out the shroud and see what happened after 5, 10, 20 years? What do shrouds do? Well, they collect water, humidity. Humidity condenses into water. They collect chemicals and salt. Now, some people may say, well, I put a drain at the bottom. Water will still stand on the gland. Chemicals will still stand on the gland. What do these cause? Well, it causes corrosion of the armor of the cable and the gland, which causes failure of the earthing. Personnel and equipment earthing, if this fails, like we talked about the gland that corroded and broke away, that's a major safety issue. It's also a great way to hide the damages, corrosion, and unsafe installations. If you look at the center picture, that gland is extremely over-tightened. Anytime you see the black on a hot gland, it's over-tightened. There's also a cut in the insulation. No cable testing was done but they put the shroud on and they hoped that nobody would find it. Now, how do I do inspections or check the gland on this one on the left? That metal cable tie is in the way. Shrouds are really inflexible. How about this one in this junction box? For initial detailed inspection, brand new installation, I'm supposed to do 100% inspection. Somebody's asking about Denso tape. I will mention that at the end. Please ask at the end that'll be a longer one. So see the cable tags there? They're stopping the shrouds from being removed. So, cost of being cheap with shrouds. They're used for the following reason. These are why shrouds are actually used. So, misunderstanding obviously, but it's great. It hides your poor works. It hides your damages, and it stops the client from inspecting our work. Now, it's great for the installer. He gets to hide everything. But what are the requirements? Well, 60079-029 markings, section 29, markings shall be visible. With a shroud on there, they're not visible. 60079-14, 100% detailed inspection. All glands and accessories shall have 100% detailed inspection. So as per -0, they have to be visible. -14, you have to do 100% detailed inspection. And -17, you have to have 100% visual or close inspection and sample detailed inspection. How are you doing 100% visual inspection when you walk by if you can't visually see the gland? You don't know what's going on with it. Well, we inspected it 5 years ago. Okay, and what's happened since then? So shrouds cause a false sense of safety and quality. They significantly increase cost and time and man hours, poor maintenance, and lack of inspections. When you're installing them, I've seen many people forget to put the gland shroud on, so they take the cable gland off the cable. The more you rework something, the more horrible it is. The armor of the cable or the outer insulation or inner insulation now becomes more depressed, maybe cold flow going on, because people are opening and closing the gland. Shrouds have no benefit besides to those who want to hide their poor quality work, damages, or stop inspections. They're a great tool for hiding all that. Now, what's the best way to do things? Well, use nickel-plated brass with no shroud, so high quality gland, or even a decent gland, and put the cable tags further back so you can actually inspect the glands. You can back them off. Give it 120 mil. So without a gland, without a shroud, you're not hiding the damage. You're not collecting water or causing corrosion. You're meeting the requirements of 60079-01417. You're not slowing down maintenance, and you're not stopping inspections. This is good for the end user. The more they see problems happen, the more they can plan to repair things. But if they can't see it, out of sight, out of mind. Cabled labels, always keep it a distance of the length of the gland away from the gland. Now, what's the easiest way? Well, this is what we at Index do. We create training procedures, methodologies, how best to supervise people. Here we had them doing barrier glands, an assembly line method at 25 Celsius in the room. We made sure that the sheath went right up the gland, up the arm, the sheath covered up the armor, all the way up to the armor clamping ring, not far away, because the back IP seal of the gland would make contact with the armor, but not the sheath. The barrier gland on the left, anytime I see a hole, failure. I get told, well, the hole doesn't go all the way through. None of us have X-ray vision. If it looks bad, you cannot verify that it's good. If it looks good, you can verify that it's good. when we talk about IP ratings of glands, most people, all they talk about is these threads, yeah? These threads into the entry into the equipment. Now, the problem is many manufacturers don't consider these threads, these threads, these threads. Now, this IP rating right here is covered, or ingress protection is covered on the cable gland, on the cable, because it has this back IP seal kind of here, yeah, that sealing ring. But these other threads are not always considered, or the manufacturer has made it where it's not practicable. One manufacturer has a deluge seal that you must pull. I can say that 99% of all glands across all sites and all pictures of that gland, nobody pulls the deluge seal. It's not simplistic for the installer. If the manufacturer does not make their gland simplistic, they're being lazy and putting the onus on the installers. 80% of all non-conformancies, yeah, punch listing within our industry is glanding and terminations. If the gland is difficult to use or, claimed to be never causing cold flow, did they test on every single cable type in the world? That is not possible. A simplistic device ensures safety. So what are the water ingress points? These points I'm showing you here within these threads. Water can get in there, cause corrosion of the armor, and break away the gland. It can also, water goes up cables. It also can go through the gland and up the gland into the device. Water does go uphill. Water does go up. Difference in temperature, pressure. Yeah, water will be drawn up. Do not think that it won't. So what can be done? Well, there's deluge seals. On this one, they have 3. 1, 2, 3. There's 2 inner seals, and then that one right there. So it's a clever design. You don't need to do anything. You don't have to pull a deluge seal. It's simplistic. It's removed the chance for human error. Instead of the manufacturer saying, well, it's the installer's responsibility, through hierarchy of control, yeah, instead of there being an administrative level of technique of you must do this, it's engineered solution. You don't have to do anything. Now, breather drains. If water can ingress into an equipment that cannot be avoided, put in a breather drain. Now, the thing is do all end users call for it in their specifications? Perhaps not. Do all EPCs use them? Perhaps not. Would you always use them on an EXP panel, a control panel, a distribution board outside? Most end users do call for it. Now, what about local control stations? What about fluorescent lights? I could have showed you more pictures. We, in the offshore and onshore industry, we find water in things at all times. This little device could be anywhere from $15 to $50, which can save hundreds, if not thousands of dollars by allowing the humidity to bleed off through the breather so that it condenses outside. And if it does condense inside, well, it drains. So a breather drain has 2 functions. This one, CMP came up with the idea of, instead of having to require an extra hole for the breather drain, they worked it into use with a gland. But you still have to put an IP washer between the gland and that accessory. They already have an O-ring built into it at the box as well. Yeah, if you have water entry through the threads here and through the threads here and the threads here, don't you need an IP washer or O-ring at the device side as well? So even the likes of other manufacturers How many times have I been told that with an adapter or reducer, you only need one IP washer? That is incorrect. You have to read the 3 documents you must always have for all your inspections and installations. Certificate, EX certificate, whether it be the ATEX, IECEx, the IOMs, installation, operations, and maintenance manuals. Who reads through all those manuals? I'm guessing 90% of you do not. It's human nature. We don't like to read. I'm not having a go at any of you. This is human nature. We're lazy people. We're lazy animals. Yeah. We don't like to read. If something's easy, cool. So the manufacturer calls for the use of 2 entry thread seals, 2 IP washers, one that side and one that side of the reducer or adapter. So on this side and this side. And if you read down in the details, it says all that, and on the certificate. Now, if the surface is not, it tells you you have to measure the roughness of the surface of the device. If it's too rough, you have to use an IP washer. Do any technicians go out in the field with a micrometer, or do you just install the IP washer? Probably best just to install the IP washer, you would think. Also, when it comes to accessories, a gland is not an accessory. When it comes to accessories, you can only install one. You cannot put a reducer and a plug. You can put a reducer and a gland. You cannot put a reducer and a breather drain. But you can put a reducer breather, a breather drain and a gland. Idea. You cannot use this and then put a plug. So we want to thank everybody for this presentation, but first, one more question. When does a breather drain breathe or drain? Multiple answers. Now, what does hot air and humidity do? Does it rise or does it fall? If you have a control panel, you have expensive electronic equipment. Yeah? You probably don't want any humidity in there. Sure, you might have a drain at the bottom, but is the humidity, the heated gas, vapor, is it escaping? Now, all answers are correct, but yeah, perhaps not put the breather on top of the device, but put it up at the side at the top. That would be the most ideal location for a breather, because when it's hot, you want it to exit the box. Now, of course, you also have to install one at the bottom, because that's where it's going to drain if any condensation does get inside. So actually, all answers are correct, but it's probably best to install 2, one at the side at the top and one at the bottom at the lowest point. Maybe tilt your box to the left or the right a little bit and make sure that your breather drain at the bottom is on that side. And perhaps have the breather version up at the side, up at the highest side of when you've tilted that box a little bit. These are ideas that work in the industry. We've had people drill holes in the EXE box to let the water out. Then bugs and dirt got in, which then caused arcing and sparking inside of an EXE box. That's a problem. So let's open it up to questions. we have a few questions already. Once again, people, we want to thank everybody that's attended. So we have some. Can you explain use of Denso tape around a JB or equipment lid? Once again, it was another idea. It's not only for IP, it's more for anti-corrosion, stopping bolts from corroding or welding. So the problem with Denso tape is on EXD, on 2A equipment, you can only have 1 inch overlap. On 2B, you can only have it butt right up against each other. And on 2C, you cannot use Denso tape. Now, what's a better solution? Well, there's silicon grease, not silicon grease all the time, but there's things like STL, HTL, standard thread lubricant, high temperature thread lubricant. In Canada, we use that on the bolts, on the flame path, on the gland threads, on the gland threads themselves. The manufacturer of it manufactures glands and they put it on the threads of the gland. And it works much better than Denso tape. Can a breather, drain, adapter, and cable gland of different manufacturers be combined? Yes, you can use any adapter or reducer with a different gland. Yeah, as long as it's the same thread, you're matching up the same threads. You don't want to cross thread and cause problems for yourself. Obviously, they need to be certified to the same scheme. Yeah, IECEx, or ATEX. If it's North American AEX, it is not approved for use in ATEX or in IECEx installations, but end users make up their own minds. Is it advisable to use polyamide glands? So I think what he's talking about is nylon glands, plastic glands. Let me explain. If the thread of your entry of your device is plastic, nylon, use nylon. If the thread entry is metallic, use a metallic gland. A metallic gland into a threaded enclosure, you will damage the threads. You will damage the wall. If you use plastic going into it, you'll damage the threads of the gland. There are other considerations, other options, but we don't have the time to talk about everything. Can you please explain again the deluge seal? The deluge seal is what we call DTS 01. So what it is these threads. These threads here, here, here. So the testing is to make sure water doesn't get into these threads, because IP rating testing 60529 is only for the entry interface between the threads of the gland here and the equipment. So the considerations for these other threads, water gets into it. So how is it addressed? Well, deluge testing. So certified to DTS 01, and it should operate automatically. Not all gland manufacturers have that. Much of the gland must be possible to resist ingress of moisture, of water. So this deluge seal, if you have to pull it as a installer, 99% of the time it never gets pulled. What is the MOC for Shrouds? Management of change for Shrouds? Or I don't know what you mean besides management of change. The reason Shrouds were chosen, because somebody had the great idea to use Shrouds and they made assumptions. Okay? That's the most obvious human answer. How do I sign up for future webinars? We have it every Tuesday at 8 a.m. UK time, and we will send out emails to everybody and also post on LinkedIn. So anybody that signed up here, you're going to receive the links. We send out a mass email. Does Index have branches in the UK? We do work in the UK. We perhaps have some partners that can help you in the field. Please contact us. Let us know what questions, what services you may ask for. What are the restrictions of top entries? That's usually a requirement of the end user or the EPC in their specifications. Obviously, if you have a hole at the top, greater chance for the water to sit there and get in, to be drawn in. So it's better to have bottom entry only, or perhaps side entry. What about lanolin grease? So this is an Australian and New Zealand idea. So lanolin grease is okay for warm environments. It is not good for cold environments. Once you start getting below 5 degrees and below, it hardens. Greases for flame paths must not harden. So it's an option, but I know of better options that are good from minus 60 Celsius to plus 400 Celsius. Please ask questions. We will respond to all questions by email. The material combination restrictions between stainless steel and nickel-plated brass. Nickel doesn't react with the most metals. I'm fairly certain it doesn't react with stainless steel. So if you have a stainless steel device, it's best to use stainless steel, Gland, but is there an option for nickel plated? Perhaps. I certainly would not use brass. When use of the cable glands with compound, for use of a double seal with a deluge seal, sorry, the question did not end. Oh, we prefer the use of cable glands with a compound seal. So yeah, the use of an EXD gland. In Canada, all our cables, full stop, we use only barrier glands on EXD, whether it be flame-proof or explosion-proof. Two different types of explosion-proof. EXD, sorry, two different types of EXD. Can we use breathers with EXD JBs? Yes. This breather drain here, at the bottom is EXD, I believe, and the top one is EXE. So yeah, and it's good. It lets the breathing, lets the condensation, it stops condensation or reduces, and then also allows to drain out. CMP Gland user data sheet states tapered threads guarantee IP66 of NPT. Adapters require thread paste to guarantee IP66. NPT is another thing. Without a thread lubricant, you're going to gall, cold weld your devices together. And as being Canadian, we know better. We know that NPT does not guarantee IP66, such as NEMA 4X. Is it rated anywhere from IP55 to 66? There's two different types of NEMA. There's a type, and then there's a NEMA. That's another story. So no, without lubricant, I would not trust NPT to be IP66. And also define wrench tight. How strong are you? Is your hand bigger than mine? Are you 50 kilos heavier than me? You probably have more strength than me. Perhaps you'll damage the NPT thread. But if you put grease, you won't, probably. If equipment is tested and certified IP66 without IP washer, does it comply with IP? Well, as per the standard, edition 7, we said that the sealing means have to be there. So if it doesn't have an IP washer, it will have an O-ring. Yeah. If this is a gland that is separate to the equipment, like they're not by the same manufacturer and as an all-in-one device, yeah, you require an IP washer. Why would you select an IP66 device and an IP66 gland, but not install the IP washer and only get IP54? That's madness. Materials of construction. Yep, that matters. Brass is a problem. The use of a breather or drain. Did this reduce the IP rating of the equipment? No, the breather drains have an IP rating. Obviously, if you're calling for IP 67, 68, 69, ensure that that breather drain is rated for that. Read the certificate, read the IOMs. Is IP washer and sealing washer are the same? Different word for it. Yeah, you can have an O-ring, a metal back sealing washer, an IP washer. I just wouldn't use a fiber washer. They absorb water. Is silicone O-ring better than nylon washer? How can we monitor the lifetime of silicone O-rings on site? Well, it depends on what type of material the O-ring is. There are white papers, there are reports on different types of O-rings that would say which ones have the greatest temperature range, exposure to chemicals, what it can withstand. If you have any questions, you're designing any equipment, please send us an email, ask us. We have this expertise. Breathing is not allowed at the bottom right. No, breathing, if you have one breather drain installed and it's at the bottom of the equipment, yeah, it breathes, but it doesn't breathe the most efficiently that it could. So if you have a fluorescent light, if you have a spare entry and there's a plug in there, I would install a breather drain. It's not going to be at the bottom, it's not going to be at the top, it's going to be, you know, halfway in between, depending on the mounting of the device. MOC, material of construction. Yeah, that's highly important. If everything's brass, I don't think that device is going to last 5 years. So manufacturers, some of them only call for their equipment to be IP54 or they make them out of brass. So they're restricting their potentials for sales. Their misunderstanding or lack of awareness is causing them to not perhaps make sales. Shrouds could be used for colder climate, definitely not in tropical countries. I come from a cold climate, Canada, -40. Once again, shrouds do not meet the standards. They hide everything from visual inspections. They do not meet the standards. They hide unsafe work, low quality work. Does sealing required to the cable gland used for an EXE enclosure, such as an instrument closure, class 1, zone 2, does sealing, well, if you want more than IP54 or a guarantee of IP54, yeah. Is sealing required for a pressure transmitter? Well, once again, if you buy an IP66 gland and an IP66 device, the only way you're going to get IP66 is install the O-ring or the IP washer, the sealing. What about aluminum cable glands? Oh, they will corrode and you have dissimilar metal problem. There's many problems. What is the most type of compound sealed widely used in the industry? Well, there's putty and there's liquid. Liquid is by far the best. It can form within 5 minutes at 40 degrees. Somebody said nickel is found in stainless steel as part of the material makeup. That's good. So you don't need to worry about dissimilar metals when it comes to stainless steel and nickel plated brass. If the internal earth plate is brass, is there any restrictions on nickel plated glands? No. Nickel will not react with most other metals. So that's the wonderful thing about nickel plated brass is it's an all-in-one solution that's high quality, safe, and ensures, well, no corrosion. If it's thick enough, you know, 10 microns or more, it really is the best solution for the manufacturer, for the end user, for the installer. It costs an extra $1 or $2 per gland, but we all have evidence of brass glands failing all the time. Okay, I want to thank everybody for attending. We still got 60 people that stuck around. Thank you very much. If anybody has any questions, what I'd like to say is thanks CMP Cable Glands. I really do like using their glands from personal experience. They have some really great ideas, and they also provided some of the details and pictures of this presentation. So thank you, Dr. Jeff. Really do appreciate it. Can a brass gland plate be used? Yes. Procedure of CMP, I can't comment on that. That is a personal assessment of somebody. Yes, Dr. Jeff, if you have something else to say, if anybody else has any other questions, please do have your input. Certain glands are better than others, but a lot of times in the industry, people give their opinion without having experience of using all the other glands. Yeah, CCG has many different models. CCG has many different models. So if anybody's mentioning CMP, it's in the questions, by the way. So to give you an idea, the Deluge seal, these are CCG glands here. They came up with an idea for a Deluge seal, which nobody had to do anything more. It operates automatically. There are alternatives that CCG make. So yeah, it's CCG makes many different types of glands. Different solutions for mining, oil and gas, the type of protection technique. Can you make comment on the importance of IP ratings of intrinsically safe? Yeah, the minimum IP 20. I don't believe that's good enough for the end users. If it's outside and it's oil and gas, IP 60, I would say. Yes, Dr. Jeff, can you ask a few questions? Yep, go ahead and ask a few questions. Make a few points. Some of the end users insist EPC to use barrier glands even after the install of the cable gland. Is it really required to have a barrier gland? Yes, I would definitely call for the use of a barrier gland in certain instances. Now, Dr. Jeff is going to make some points right now. Dr. Jeff, go ahead.
Hi, Mike. I just wanted to make just wanted to comment on your presentation there.
Sure.
I'll pull you on one thing. Brass glands are not cheap. Brass is not a cheap material. I don't want people to think that they are inferior in some way. They are cheaper than nickel-plated brass, for sure. But brass is chosen for some very good electrical reasons for making cable glands with.
Correct.
Also, the breather adapter that you showed, you credited CMP with that. That was actually a product designed by CCG. It's unique to us.
Yeah, this one here, this is CCG.
Yeah, that's the one, yeah. Is to solve the problem of needing a breather when you haven't got an extra entry hole on your equipment.
Correct.
Also, you've commented about breathers working best at the top of an enclosure. Very often you'll find that the breather has to be installed at the bottom as part of its certification. And the reason for that is very simple. Breathers let water out. They also let water in. So
Correct.
unless you install them at the bottom, they cannot drain out fast enough to achieve an IECEx rating. Now that rating can be achieved even though water has got in during the test, as long as it doesn't get in too much and it drains out quickly. So that's why they must be installed at the bottom of the equipment.
Correct. So
there were small things as well. You commented on thread galling on MPT threads. That will only happen if the cable gland is the same material as the enclosure. However, I fully agree with your comment about using a thread lubricant, a grease, when you install these. If you don't, you cannot guarantee your IP rating.
Correct.
Finally, one little comment on the plating thickness of the nickel plating. Until a few years ago, you were limited to 8 microns of plating on a cable gland. That restriction was lifted, and the general consensus is that less than 10 microns, what you have is decorative. 10 microns plus, what you have is protective. So it's very, very important to specify at least 10 microns of nickel plating, and preferably a marine grade nickel plating, because not all nickel plating is the same.
Mm-hmm.
Okay.
Thank you for your inputs. When I was talking about breather drains, people, by the way, what I would mean is if you were to have a breather drain at the top of the device is not a great idea, but on many control panels within the oil and gas industry, they installed 2 breather drains, one at the bottom, which does meet the certificate. Now, the idea of putting it on the side up near the top, not on the top of the device, but up near the side, while that kind of goes against the certificate, perhaps the certifying body needs to have a think about that, and the manufacturer. The idea of having it up near the top is that when you have a big enclosure that lets off a lot of heat, it's good to let that heat out. And also, if there's any humidity, water vapor inside, it allows it to escape as it heats up. So if you're going to use 2, yes, you must always, as Dr. Jeff said, that you must have it at the bottom. But there are instances where 2 have been used and one's up near the top, not on the top, but near the top. Okay. Explain the use of a star washer with a gland. Anti-vibration to stop the gland from backing out, and also potentially for earthing. If you only have like less than 6 millimeters of threaded entry, is that IP washer earth? Have you used a banjo, an earth tag? Somebody gave the answer, always use grease. Yeah, that's a good idea. As Dr. Jeff mentioned, yeah, you won't get IP66 on MPT unless you use grease. When I say galling, yeah, on similar metals, on the same metals, is an IP washer required on an EXE box being used for intrinsically safe circuit? By the standards, no. You only need the meet IP, you know, it's the end user's requirements, but really, why not make everything IP66? If you're offshore oil and gas, why not make everything IP66? Why not maintain the highest level of protection? Why not let the manufacturer have a high quality device that operates for a long period of time where they don't have to replace it? So I'm thinking best practices, yeah? Any other questions, or I think that will be the end of the presentation. Still 50 people hanging around. Thank you very much. Okay, I would like to thank everybody for Index webinar number 5. I would like to thank again CCG. They have some great ideas, great device options for perhaps for you people, your organizations. I really like this breather drain / entry device. Allows you to use the gland, and other ideas like their deluge seal that guarantees no water gets in. Yeah. So once again, thank you for your time. Next week will be number 6. Please make comment on the survey afterwards. Open to any and all comments, suggestions, questions. Thank you very much for your time.